You have studied food preparation in the first lecture of this module, and in this lecture you will gain knowledge about fundamental characteristics of food that include their physical, chemical and biological properties. These characteristics determine how food look, taste and feel, and as well as how they react during processing and cooking. Food science studies these properties to ensure foods are safe, nutritious, and appealing. The nature of carbohydrates, proteins, fats, vitamins, and minerals in the food affects its nutritional quality and how it changes with cooking. Understanding these characteristics helps food scientists develop better food products, improve preservation, and enhance health benefits for consumers. So let's start with the introduction. That food are materials that humans consume in their natural, processed, or cooked forms for nourishment, sustenance, and enjoyment. Food items include a variety of groups such as food grains like cereals, which includes wheat, rice, sorghum, millets, etc. Legumes or pulses, which includes red gram, black gram, green gram or beans, etc. And we have horticulture produce including fruits, vegetables, spices and condiments. Livestock produces such as meat, eggs and milk, as well as fish and seafoods like prawns and carps. Beverages like tea, coffee and cocoa also fall under the category of food. Understanding these diverse food types helps in planning, balancing diets and nutritional intake. There are several uses of food. Food comes from a natural source that are cultivated, reared, captured or cultured. Some foods can be eaten raw, but most require processing to develop desirable qualities that make them acceptable, editable, and digestible. Food is fundamental to life, providing nourishment and energy essential for survival. Early humans experimented with different forms and taste, leading to the development of culinary art, the creative and skilled preparation of food. This evolution reflects the cultural and social significance of food beyond just sustenance. The properties of food can be broadly categorized into two critical aspects that are nutritional value and hedonic value. Nutritional value refers to the essential nutrients food provides to support bodily functions and overall health, whereas hedonic value relates to the pleasure and sensory satisfaction derived from eating, including taste, aroma, texture, and appearance. While nutritional value ensures food meets dietary needs, hedonic value influences food choices and intake through enjoyment. Understanding both aspects is crucial for developing foods that are not only healthy but also appealing and satisfying to customers. There are several properties of food. The property of food encompasses various physical and chemical characteristics that determine its quality, safety, and consumer appeal. Geometrical properties refer to the physical form and shape of food, affecting how it looks and is handled. Optical properties includes color, surface appearance and gloss, which are important visual indicators of food quality. Rheological properties describe how food flows and deforms, influencing texture and mouthfeel. Thermal properties involve the transfer of heat during cooking or cooling, impacting the safety and sensory qualities of food. Mass transfer properties refer to the movement of moisture, vapor, gases, and flavor compounds during the processing and storage. which can affect shelf life and taste. Electrical properties measure how much energy food absorbs and distributes, which is relevant for processes like cooking and quality control. Together, these properties provide a comprehensive framework for evaluating food quality and optimizing food processing techniques. Now we will discuss about geometrical properties of food in detail. Geometrical properties represents fundamental physical characteristic of food that encompasses dimensions such as its size, shape, volume, density, and surface area. These attributes significantly influence how food behaves during processing, packaging, and transportation, as well as its overall quality perception. For instance, fruits and vegetables can be categorized into various shapes, including round, oblate, oblong, conical, elliptical, and translucent form. A key parameter is sphericity, is used to compare the shape of a food item to an ideal sphere, providing insights into its compactness and flow behavior. Quantifying these properties not only aids in optimizing equipment design and processing parameters but also ensures uniformity and consistency in food products. Understanding geometrical properties is thus crucial for enhancing both the efficiency of food processing systems and the consumer experience. Now, the volume is a fundamental property that is relatively simple to measure, especially for liquid foods, provided the temperature is properly controlled. Density, particularly for solid foods, can be determined by using flotation methods with liquids of known densities such as salt solutions. This approach helps in identifying the compactness and mass per unit volume of the food item. Surface areas play a critical role in heat transfer processes and can be calculated using various methods based on shape factors, especially for irregular objects like fruits. Accurate measurement of these properties is essential as they affect many aspects of food processing, storage, and quality control. By understanding volume, density, and surface area, food scientists can better predict how food responds to different treatments, ensuring safety and quality from farm to table. Now we will discuss about optical properties of food. Optical properties play a crucial role in determining the visual quality and consumer appeal of food. The most significant optical attribute is color, which arises from the way food materials absorb, reflect, and transmit light. Color helps consumers judge freshness, ripeness, and overall quality even before tasting. Besides color, gloss, reflecting the sheen on smooth surfaces, influences perception of freshness and texture. Translucency refers to translucency refers to how much light passes through foods, affecting their appearance, especially in liquids like fruit juices. These properties are not only assessed visually but also through instruments like colorimeters and spectrophotometers that provide objective, consistent measurements. Understanding and controlling optical properties are essential for ensuring food products are attractive and meet consumer expectations. Now we will discuss about rheological properties of food. Rheological properties are fundamental to understanding how food materials deform and flow when subjected to external forces. Due to the complex and varied structure of food, their flow behaviors are diverse and range from solid solid-like to fluid-like characteristics. Rheological testing of food is generally categorized into two main types, that is fundamental and empirical test. Fundamental test measures intrinsic material properties such as the modulus of elasticity and shear modulus, which are independent of external factors like sample size or testing conditions. Conversely, empirical tests evaluate practical parameters such as puncture force and extrusion energy, which are influenced by factors including sample geometry and the speed of testing. Because food typically exhibit viscoelastic behavior, combining both time-dependent and time-independent measurement is essential to comprehensively characterize their mechanical response. Understanding these properties supports optimizing food processing techniques, ensuring product consistency and enhancing sensory qualities critical to consumer satisfaction. In the study of food rheology, tests are conducted under different conditions to understand how food materials respond to forces. Static or quasi-static tests measure the material's response under slow or no movement, providing insights into how food behave under gentle or sustained pressure. Dynamic tests, on the other hand, assess the behavior of food under varying stresses and strains over time, stimulating real-world conditions such as chewing or processing. Foods are inherently viscoelastic, meaning they exhibit both elastic or solid-like properties and viscous or liquid-like properties. Consequently, to fully characterize their rheological behavior, both time-dependent and time-independent measures are essential. The evaluation of rheological properties can be divided into two broad classes. They are measured into two main categories of test: fundamental test and empirical or imitator test. Fundamental test measures a material's inherent properties which are independent of the specific sample geometry. For example, material stiffness, the material's ability to contract or expand perpendicular to the compressive force, time required for stress to dissipate in a material under a constant strain, material's rigidity or resistance to shearing. Whether empirical or imitator tests are used to determine properties such as puncture force and extrusion energy, where the mass of the sample, geometry, speed of the test, etc. also determine the parameter estimated. The fundamental test as applied to solid food may again be classified into two essential different groups: those divided under conditions of static, quasi-static loading, and those considered under dynamic conditions. Because foods are viscoelastic, both time-dependent and time-independent measurements, now we will discuss about thermal properties of food. Thermal properties are essential for understanding heat transfer phenomena during the heating or cooling of food materials. Due to the diverse consumption and physical characteristics of food, these properties vary widely across different food types. Key thermal properties include specific heat, which defines the amount of heat required to raise the temperature of a unit mass by 1 degree. Enthalpy, that representing the total heat content. Thermal conductivity, which measures the ability of the food to conduct heat. Thermal diffusivity indicates the rate at which heat diffuses through the material, and the heat transfer coefficient describing the efficiency of heat exchange between the food and its surrounding. Accurate knowledge of these properties is critical for designing efficient processing operations, ensuring food safety, preserving nutritional and sensory quality, and optimizing energy consumption during thermal processing. Now we will discuss about mass transfer properties of food. Mass transfer is a fundamental principle in food processing that governs the movement of substances such as moisture, vapors, gases, and flavor compounds within and between food materials. It plays a critical role in various physical, chemical, and biological processes, including salting, sugaring, oxygen absorption, deaeration, and the cleaning of processing equipment. Effective mass transfer management is essential during food processing and the storage because it directly influences food quality, shelf life, and safety. By understanding the mechanism of mass transfer, such as diffusion and convection, food scientists can optimize processes like drying, marinating, and preservation to enhance the sensory and nutritional properties of food products. Now we will discuss about electrical properties of food. Electrical properties of food determine the amount of energy absorbed by a food product and how this energy is distributed within it. These properties are especially significant in high frequency food processing methods such as pulsed electric fields, ohmic heating, induction heating, radio frequency, and microwave heating. Biological material typically act as a heavy insulators or non-ideal capacitors, meaning they have the capacity to store and dissipate electrical energy when subjected to applied electromagnetic fields, primarily through radiation transfer. Understanding these electrical characteristics is essential for optimizing processing efficiency, ensuring uniform heating, improving food safety, and maintaining the desired quality attributes of the product during electromagnetic food processing techniques. The food quality is determined by its sensory attributes like taste, aroma, texture, and appearance, chemical composition, physical properties, microbiological safety, shelf life, and packaging and labeling. Understanding these characteristics and using appropriate measurement tool is essential for effective quality control and assurance. Together, these factors ensure that food products meet consumer expectations and safety standards. When selecting food, we use our senses. For example, we use our sight, touch, smell, taste, and hearing to evaluate the quality of food. This process is called sensory evaluation. It helps us to judge food based on its appearance, aroma, texture, flavor, and sound. Our senses work together to create an overall sensory quality, guiding our food choices and enjoyment. Sensory evaluation is essential for food acceptability and quality assessment. Food quality is determined by several sensory properties that we perceive through our senses. These include appearance, which gives us the first visual impression, color, which indicates freshness and appeal, texture, which affects how the food feels in the mouth, and taste and flavor, which directly influence our enjoyment and our preference of food. Sensory evaluation uses three senses: sight, touch, smell, taste, and hearing to assess and judge food quality. This evaluation is essential for ensuring a food product's acceptability, and thus manufacturers improve quality to meet consumer expectations. Through sensory test, characteristics like flavor profiles and texture details can be measured, guiding product development and quality control. Sensory evaluation combines objective observation with subjective experience to create a complete picture of food quality. Humans evaluate food using sensory properties like color, size, and shape, which significantly influence visual appeal and acceptance flavor. Flavor is determined by a combination of taste like sweet, sour, salty, bitter, sensed by taste buds, and odor, which is detected as aroma through the olfactory system. The physical aspects of food refers to its texture, viscosity, and consistency, describing the food's physical state and behavior. Kinesthetic factors or body feel includes finger feel features like firmness or stickiness, and mouthfeel descriptors such as chewiness, grittiness, or smoothness, providing additional dimensions to sensory evaluation. Sensory evaluation in a scientific method of using human senses to judge the quality of food. Our five senses, sight, smell, taste, touch, and hearing, work together to provide a complete sensory profile of a food product. Sight helps us perceive color, shape, and surface qualities, while smell detects aroma, which plays a major role in flavor perception. Taste buds identifies basic taste. Texture is experienced through touch, including mouthfeel attributes like chewiness or smoothness. Even hearing attributes, for example, by detecting the crispness of food, can be used. Sensory evaluation methods, including difference test and descriptive analysis, allow trained panels to methodologically assess these attributes, guiding product development, quality control, and ensuring customer satisfaction. Understanding sensory properties helps create food that delight the senses and encourage acceptance. Color and other aspects of appearance play a vital role in how consumers appreciate and judge food quality. The visual appeal of food, especially its color, often forms the first impression and can strongly influence buying decisions. Changes in color are sometimes linked with the undesirable changes in texture, taste, or odor, which further affect perceived quality. Consumers expect foods to have certain colors associated with freshness and quality. When products deviate from these expectations, it may lead to resistance in purchasing or acceptance. The functions of food appearance and color go well beyond aesthetics. They are deeply tied to human psychology and learned behavior. Color perception plays a vital role in food selection and quality judgment. Without the ability to distinguish colors, evaluating food quality would be extremely challenging, even if other cues like size or texture were present. Color influences motivation by affecting appetite. The color of food and its surrounding can either enhance or reduce our desire to eat. Our emotions also play a part, as attractive colors make foods more appealing and pleasurable, while unattractive color discharge consumption. Learning shapes our expectations of what color food should be based on our past experiences, allowing us to predict a food's property accurately. Finally, our thinking and attitude towards a novel or unusual foods can change based on explanation or contextual understanding, demonstrating the powerful influence of cognition on sensory perception of food. The food texture is a complex sensory property defined by mechanical, geometrical, and moisture related characteristic of a food product. It is a critical component of a consumer's overall eating experience and can significantly influence a product's acceptance. For liquid foods, texture is closely related to their viscosity. Texture is an important sensory property perceived by both sight and touch, including sensations felt in the mouth and by the skin. It describes characteristics like roughness, smoothness, graininess, firmness, softness, juiciness, chewness, and grittiness. Sensory evaluation of texture can be subjective using hand feel or mouth feel experiences, or, or objective using instruments such as pentometers and refractometers to measure texture in cooked, canned, and frozen foods. The surface of the tongue and the other sensitive areas in the mouth react to food's texture, influencing overall acceptance. Texture may be assessed through touch or mouthfeel. When the food is placed in the mouth, the surface of the tongue and the other sensitive skin reacts to the feel of the surface of the food. Textural factors therefore include assessment through the hand feel and mouth feel such as firmness, roughness, juiciness, chewness, and grittiness. Food texture is made up of various components that can be objectively measured using standardized items. These includes mechanical properties such as hardness, which is the force required to deform food, cohesiveness, defined as how well food holds together before breaking apart, and adhesiveness is the force needed to remove food from a surface, while denseness describes the compactness of the food's internal structure. Springiness refers to how quickly a food returns to its original shape after being deformed. Additional textural sensations like geometrical properties as smoothness, grittiness, graininess, chalkiness, fibrousness, lumpiness, and moisture properties as juiciness, oiliness, and greasiness. Understanding these properties helps in the food formulation, quality control, and ensuring customer satisfaction by delivering desirable textural experiences. Flavor is the overall sensation we experience while consuming food. It is a complex combination of taste and aroma. While taste is sensed by our taste buds, detecting sweet, sour, salty, bitter, and umami, and aroma is perceived through our nose by volatile compounds. Texture and color also influence how we perceive flavor, shaping our enjoyment and preference. While instruments like gas chromatography can measure flavor components, the ultimate taste of flavor is human sensory evaluation. This sensory experience is subjective and deeply connected to our memory and emotions, making flavor an essential aspect of food quality and acceptance. Flavor is a Flavor is a complex sensory experience that includes odor, taste, and chemical feeling. Odor is the olfactory perception caused by volatile substances. Taste refers to the gustatory sensations detected by taste buds on the tongue. Chemical feelings involves stimulation of nerve endings in the soft membranes of the mouth and nasal cavities, producing sensations such as spicy, heat, cooling, metallic taste, etc. Together, these components create the full flavor profile of food. This diagram illustrates the process of sensory perception for both taste and aroma in food. It shows that taste compounds interact with taste receptors, while aroma substance activates odor receptors. Additionally, the odor threshold, that is, the minimum concentration required for detection, is compared for potency, highlighting how sensory systems measure and evaluate the intensity of smells and flavors using specialized receptors and comparison methods. Flavor is a complex sensory attributes arising from the combination of taste and aroma compounds. Taste compounds are mostly non-volatile and interact with taste receptors on the tongue to produce sensations. Aroma compounds are volatile molecules detected by olfactory receptors in the nasal cavity. The interaction of these compounds along with texture and color influences flavor perception, which remains subjective and difficult to quantify. Food aromas can be classified into four groups based on their chemical composition. In group 1, a single compound predominantly carries the aroma with other adding minor notes. This is typically of fruits and vegetables. In group 2, we involve the several interacting compounds where one plays a major role, such as in butter and blue cheese. In group 3 aromas, there are complex compounds can be closely replicated by mixing many compounds, some of which may not be naturally present, for example, including roasted coffee and bread. And group 4 aromas cannot be satisfactorily reproduced even with numerous volatile compounds as seen in cocoa and butter. Thank you, students. This was all about the second lecture of this module. Now in the next lecture you will be getting information about some more characteristics of food in detail. Thank you.